Hey, good morning everyone and welcome to our crash course. Today solving data bottlenecks with GenAI. This will be a session packed with content and will fly relatively quickly. So we are going to try to walk you through showcasing as much as possible how all of the peskiest bottlenecks that we have found and we have seen unchanged across the last few decades can now be solved or at least eased with generative AI. We only have so much time, so without further ado, we are Solita. We are pretty much a data company from the Nordics, operated in all data-related domains. Since 1996, we are now surpassing 2,000 experts in the different fields of data manipulation. And we operate a little bit all over what we like to call the beer-drinking Europe, Belgium included, in 2 locations. Allow me to butcher the names with the accent, Leuven and Ghent. So my name is Fernando Polonia. I've been leading the business unit here at Solita, the data business unit. I've been in the industry for about 15 years now, always related to data, be that data visualizations, data engineering, architecture, governance, pretty much end-to-end. Lately, more directly involved with architecture and road mapping, agnostic tool selection for a large retailer in the domain of data governance. And joining me is...
So I'm Radia Belessin, working for Solita as an AI lead. I've been also working in the artificial intelligence industry for the last 8 years now. And what does it mean practically? I've been working on over 50 projects, different industries, from retail to pharma to public sector, banking, whatever you name it, now material handling. And we hope that today we'll be able to bring you interesting content and interesting insights on that topic. So let's start with the agenda. So basically, now that we have kicked off with the first introduction, we'll first look at the data evolution journey. So what we mean by that is basically we want to know a bit how handling data has evolved over time, and basically how we moved from simple storage to complex data platforms. Then after, we'll look at the data bottlenecks. So basically, we'll go through the top 5 bottlenecks that we have noticed in the industry and at our different customers, and basically try to understand a bit like why they happen and how we could tackle them in general, and basically also how they relate to the data evolution journey in general and on that timeline and the different generations. Then after we'll go through the quest for solutions, we'll first start with some traditional approaches to understand a bit better what has been already tested actually in the last few years to basically tackle all those challenges. And then after we'll introduce the new hope, so how artificial intelligence can actually help solving some of those data bottlenecks. Then in the second part, we'll go through generative AI in action. This is like where the fun part is, basically. We'll explain a bit first what is generative AI, how it works, and then go through some real-life examples to explain a bit how it can tackle the different challenges and bottlenecks that we presented before. Then we will look ahead and think a bit about the future. So what are the top trends, how it's evolving, what we can expect in the next few months and next few years in terms of evolution in generative AI related to data management. And for the last part, it will be like maybe one of the interesting part for you is really like getting you prepared. Are you ready to embark? What do you have to think about if you decide to really implement some generative AI solutions at your company? Then after, we'll close up with a Q&A session, so if you have any question at that moment, you can fire them up, and we'll be glad to answer. Are you ready? Then we can get started.
Right, then we start with the data evolution journey. So pretty much over the years, the data platforms have evolved. They have evolved always to respect the needs of the changing organizations. So as things moved along, we started with the traditional BI systems. So what we refer commonly today as data warehousing was pretty much a first iteration, a first go at storing structured data and using it for reporting and analysis. So usually we're talking about strategic decision making. Of course, it involved both hardware and software, usually proprietary of both. Then we have the evolution of data starting to becoming more disparate, different, sometimes more unstructured, and the velocity of that data increased as well. So we went to a new technology that was data lakes, pretty much able to process, to store large amounts of raw data that would be processed later. So here, once again, we have cost of infrastructure that pretty much grew a lot, and the cost of complexity as well. So as we started to move more and more to the cloud, and of course, all the technological evolutions that came with it, that made that move possible, we started to see the birth of cloud data platforms. So these were pretty much integrated platforms, or are pretty much, that's still a current generation, where you see that you can have all of the benefits of the traditional, all of the benefits of the data lakes, but you don't have anymore the startup cost associated with it, and you don't have the complexity anymore of managing nodes and other technical complications. So pretty much cloud data platforms came to fix yet another bottleneck, but it was always technological. So if we look at the first three generations, we're always talking about a technological change. Now, in the fourth generation, we actually see that ultimately the bottleneck are the people, are the human factor. So we're talking about data teams, and data teams being cramped with a high workload. So the fourth generation came with the distribution, and here we're talking about the data meshes, the data product thinking, and it's the first time that we are addressing the human factor. But at the end of the day, what we have seen is that all of these changes, some challenges remain the same, almost unchanged. No matter in which generation we are, we find the exact same issues. So what are those issues that we still have? We're going to look at them, and these are issues that we have identified on the field from our own experience as being constant, unchanged for decades now. And these are the five. So quality, integration, the discoverability, and accessibility. So that counts as 2, and compliance. So pretty much quality is data quality. And no matter which company you go to, you will find someone with a data quality issue. The issue really is trust on the data. Do I trust this report, or is something wrong with it? I haven't been in an organization yet that there's a report and someone says, I trust this 100%. Integration, we go back to that manual process. So we have a team of data engineers that manually need to write pipelines. And as the company grows and grows, this becomes a bottleneck. Discoverability and accessibility is pretty much trying to find the data and getting value out of the data. And unfortunately, today, still what we find in companies is we ask around. Where can I find this information? And finally, the compliance. Now, a lot has been done in compliance in the last few years, GDPR being a very hot topic. Nevertheless, what we see across the board is there are implementations of the GDPR and an effort in compliance operationally, but as soon as we go to the data team, it's out of scope. So it's just ignored, pretty much putting the head in the sand and ignoring that that exists. Which brings the question.
Yeah. The big question, which of those challenges are you currently experiencing? So before we go through the different challenges, I will put them back on the screen so that you remember. But for the online audience, you can also have, in the chat, you will see that you received a poll. You can directly vote and you will see the results updated live. But for the on-site audience, I would be quite curious. Let's go through each of them and then just raise hands to see a bit what has happened. So in terms of quality, have you ever experienced or faced that issue in your company? Okay. Integration. Discoverability and accessibility. Okay. And compliance. Yeah, I think we get a winner. So yeah, I think the big bottleneck seems to be today the discoverability and accessibility, but what we can see is that each of those challenges has been faced by at least one person today.
All right. So moving on, the quest for solutions. Now, finding solutions to these bottlenecks is not something that is new. Of course, it's hard to imagine that if they have been there for decades, how come nobody tried to fix it. And in fact, yes, we have. But the fix is always the automation through coding and algorithms. So we're talking about coding and tooling. Now, the problem here is that it does have a limit. That is, everything that we can code, we have coded, and everything that we can't code is now with the data team. So in fact, everything that has to do with data quality rules, they have to be written by hand. This is one of the reasons why data quality is usually not implemented at companies. It becomes too big of a cost to have some benefit. We have used templates for ETLs. BIML, for instance, was quite popular. But everything else is manual work. And as you can see, when we're talking about requests to technical users, if a business user needs information and cannot access a database or know how to interact with a database, they will request to a technical user. All of this puts more load on the data team. So the already strangled bottleneck, all of these, except for compliance, which we are ignoring, and we are ignoring it not to put the extra load on the team, because otherwise the team doesn't do anything else, right? So that's the issue that we have, and these are the traditional ways of approaching. Now we do have a new hope, and that is artificial intelligence automation. Pretty much everything is generated for revision, data engineered, checks, and validates. And requests to technical users are now replaced by interactions with chatbots or AI assistants. And finally, when we talk about compliance, we can almost generate everything compliance related. And we will go a little bit deeper into this in just a minute, not to give too much away in one go. But so pretty much AI can automate the majority of this, and it increases the performance of the data team. So Radia will walk you through a little bit more in-depth how generative AI can achieve these outcomes.
Yes, thank you, Fernando. So before diving into what we can do with generative AI, I think it's important to understand a bit like the main terminology that you will have when you're talking about generative AI, especially with the fact that we often hear a lot of buzzwords related to AI in general. You will have like artificial intelligence, machine learning, deep learning, now generative AI. Okay, but how those differ from each other, basically? So let's start in the 1950s with artificial intelligence. It's actually where it all began. And it's basically how you will teach a machine what a human brain would usually be needed to do, basically. Some task basically like, for example, understanding speech or playing chess. Usually you would need a human brain to do it, but then artificial intelligence was introduced to perform that kind of tasks. Then after, fast forward to the 1980s, you will have what we call machine learning. And here it's really like giving a machine a personal tutor. So instead of having to program every single rule manually, now you will feed it data and let it understand a bit some patterns and interesting insights and let it take some decisions, basically. So they will be very good usually at performing some complex tasks, like, for example, recognizing automatically some fraudsters among your customers, or like, for example, recommending you what movie to watch next. Then what you will have in the 2010s is the appearing of deep learning. And deep learning, it's very simple. It's like just a special part of machine learning, but it's really where it gets brainy, and quite literally, actually. Because what you will use in deep learning is often what we call neural network. I don't know if you heard about them in the past, but basically it's just like a simplified version of your brain network and how it works. And you will feed it quite a vast amount of data. And doing this, what you will get is really getting like a machine that is quite good at applying and realizing some complex tasks. For example, like driving cars, or even like translating languages and things like this. Then what you will have into 2020s is like just a few years ago, actually, is really the new kid on the block. So what we call generative AI. And here it's really like where machine learning gets creative, actually. So you will not just have data fed into a model that will understand patterns. It will be able not only to understand the patterns, but also to start generating new content. So let's imagine that you have like a machine that heard, let's imagine like 1,000 of songs, and will now be capable to create a new song that you never heard of before, that will be completely new and unique, but completely generated by a machine. What is quite important is also to understand that each of those concepts are really like building on top of each other. It's really like a chain of evolution that will basically be possible with the help of the other ones. So without artificial intelligence, you would not have machine learning. Without machine learning, you would not have deep learning. And without deep learning, generative AI would not be possible today. So it's really like adding a bit more intelligence to each of the different steps, basically, to make it feasible to apply super complex tasks in the end. So, what is generative AI concretely and how does it work? So, let's imagine that you have a massive virtual library that keeps augmenting over time and that keeps growing. This is what we'll call our massive data. And in this, you will find any type of different information. You can have text data, you can have images, audios, videos, even code sometimes. And what you will have is basically those data that will be fed into what we call a foundational model. And the foundational model, it's really the brains of the operations, if you want. And this is where you will use that virtual library to really learn the patterns, the complex patterns that are present in your data, and that will be then after able to generate new content and really understand what's happening in your data. So for example, you can imagine like having a chef who tasted like 1,000 of dishes, and you will now teach them like the recipes that they can use and let them cook a new dish completely new for you and unique. Then you have on the right side the different tasks. It's basically just the task that you will usually ask the model to perform for you. And it can be, for example, just a discussion in natural language. It can be the generation automatically of code. You can have like just composing a melody, editing a film automatically, etc. And in the bottom, you have the user request, and this is really where you come into action. You will just give a prompt or ask a question to the model, basically. And based on that question, it will use all the massive data that it has available and the question that you ask to really come with an answer that is unique and really fitting the needs that you have, basically. So, how do large language model works, or LLMs, as we call them in short? So let's imagine that you have 1,000 of puzzle pieces. And each of those puzzle pieces are basically just sentences or words. And the goal of the large language model is to put them together to create a puzzle that you will be able to recognize and that will make sense for you. So how does it work? It has been trained on a huge quantity of data, of text data specifically. It can be like text data coming from books, coming from websites, from whatever text source that you could have. And it will learn from those and really understand a bit like all the grammatical patterns that you will have, all the grammatical rules, what does it make sense, how you will build like a sentence that is sounding really like the ones that a human would say, basically. And based on this, it will generate for you some new sentences that are still making sense for you, basically. So it's really putting together the different puzzle pieces in a way that makes sense. It will be able to understand in this diagram, for example, that we see that you can say, okay, to go or to be, but that two diamonds would not make sense grammatically, and it's not something that you will be able to hear, for example. And it will come with a sentence that is really making sense. So now that we have introduced really like the basic concepts of generative AI, what is quite important to understand is that many companies have already started to invest into generative AI to look a bit at what you can do with it, investigate some use cases, etc. But there are like some cases that you will really often hear about, some cases that are coming way more often than others. For example, you will hear about like a product design team that wants to like have a new innovative concept that they want to put in place, or like marketing team that needs to come with a new blog post every single day. And for that, they really need to be like working during hours to generate a draft, etc. Now it's feasible with generative AI to automate that part, basically, so that you already have a draft and that the team will be able to focus more like on the refinements, on the editing of that draft to come with something that is really valuable instead of spending hours and hours just to come with a first draft that needs to be reviewed out after. And you also have like, obviously one of the cases that is super known is everything related to customer support. Having chatbots, we have chatbots for years already on the market, but now the big difference with generative AI is that you are really able to have like interesting discussion with those chatbots. You can ask questions and get answers that really seem to be fitting your need and understanding what you need instead of having to type exactly some keywords to be able to get an answer. But what we don't often hear about is the cases related to data initiatives, actually. And this is where it will get interesting today. So, coming back on our data bottlenecks, what we have is, as mentioned by Fernando before, we'll go through them quite quickly, but you have quality. So the question is, okay, can generative AI help making those data quality issues into data quality diamonds, actually, just by having some cleaning that is AI-powered, for example? Compliance, can we make sure that those compliance guidelines are followed properly? Integration, can we have the integration of disparate data done automatically and without having to spend hours and hours and days even doing this manually? And discoverability and accessibility, can we really have different types of users, from data engineers, data analysts, data, even like business analysts, playing with the data and able to access those without having troubles and going around like the 30 floors of your company to go ask, where can I find those, basically. So for that, let's go through the first challenge, which is data quality using generative AI.
Right, starting with data quality. So we can classify the contribution in pretty much these three axes. So the data validation and cleaning, the data augmentation, and the data testing. Now, we're going to go one by one, just to make sense out of this text. So when we're talking about data validation and cleaning, we're talking about detecting patterns, outliers, but we are detecting something that we could do ourselves manually. All right. So writing checks, detecting patterns, making sure that those patterns are followed. So let's go through an example. If we have a small field with a product code, and that product code is consistently done, constituted of 6 letters, if we find a digit in there, or if we find 7 letters or a larger string, then we know that's an outlier, we know it shouldn't be there, we know it's probably a data quality issue, right? So this is something we could do, but it's something that we can automate as well. When we're talking about data augmentation, we are looking at the identification of patterns that we can't do. So we cannot look at the data and say, I see this pattern. So human eye is really bad at this, and AI is really good at this. So when we're talking about data augmentation, we're talking about those patterns that we cannot find, and we're talking about finding balanced data sets. So when we're doing a classification, we are sure that each bucket is of the same size, let's say. So again, this is something that we can rather do, but it's rather time consuming. So we can now do it much, much faster with generative AI. And finally, we have the data testing, and we can split this a little bit into 3. 2 is okay, but that second one is part of a duo. So when we're talking about testing, we always go through generating a test scenario, let's say stress testing. So we want to make sure that the algorithm, the program that we have, follows through at a given performance. We are stress testing it, and we need to define a scenario that is realistic. We need to code it, and we need to have the data that supports it. So what we can do now is actually generate all 3. AI can generate the test scenario that is very realistic. It can generate the data so that we can write the code, and in fact, it generates the code as well. So pretty much all three steps, it's the test scenarios and the test data that go together, can be done by generative AI. And in fact, Radia will walk you through exactly a real-life scenario, real-life example of a data standardization implementation.
Yeah, thank you, Fernando. Absolutely. I would even say that it's really like a data cleaning scenario that we got here. So basically, it's a case that we have done for a material handling company. So just to summarize a bit what's their business, basically to understand what they do. It's a company who usually rent or sells some material handling equipment like forklift, etc. And what they will do is also take care of everything that is related to service and maintenance. And when you think about service and maintenance, usually what the big question that you get is, okay, are we able to predict when the new repair that will be needed will happen, basically? So what we call predictive, predictive maintenance. So for that, it's important that we can rely on past repairs and interventions that happened just to make sure that we can predict the future ones. And what we get in the data that can be used for this is some intervention forms that are filled in by the technicians. So when they go on a site, what they will do is basically fill in like a form mentioning, okay, what happened, what was the root cause of the issue, what were the actions taken, etc. And they have like two parts. A first part that is like filled in with just some drop-down buttons so they can select different categories of error categories and actions taken, etc. But they also have free texts. And those free texts are usually shared with the customers. So we noticed that they were of quite good quality, actually. There were like full sentences explaining what happened, what they have done that day, etc. Whereas like the comments that were, the fields that were like filled in by the drop-down, we noticed that there was like some randomness into it for some reason. They were like choosing the different fields, but we really noticed that the quality was not that good for those. And the question was, okay, can we use generative AI to extract those fields that we use that are already like classified, but from the text comments, from the root text comments, free text comments that were mentioned by the technicians and that were like of very good quality. So let's take just one example of a text comment that you will have in the data, just to illustrate a bit. So we have a comment here which was install new flashing light and altimeter due to impacts. But for some reason, when you look at the drop-down selections that were done on that same form, you have error cause deformed, error category machine dead, action name customer damage. What we can see is that it's not saying much, especially if you want to do like a predictive maintenance or train an algorithm on this, you will not get that much value for this. So what you will try to do is use those free texts coming from the technicians and try to really use some large language models to extract the interesting information. And what we have in this company specifically is that it's like an international company. It's something that often happens. And the free text comments are like in every single possible language that you will find at those customers. It's almost never in English, but to really be able to have like reporting that is done to train a model, etc., to have proper classification, what you would like to do is first to have like a translation and then after extract the information. So let's go through the process that we had. So first, comments, it's exactly the same as we have seen before, but it's in Spanish. It was like the original language. And what you will do is basically use here Azure OpenAI API and give it a prompt, so very basic use case at this stage, and you will give it like some specific indication. You will mention, okay, given the following comments from a technician during a work order on a material handling vehicle, and then you put the comment in question, which is in Spanish, carefully analyze the text and provide detailed insights following these explicit guidelines. And then here you can list your guidelines and say, okay, first translate, then select like the root cause, then identify the action taken, etc. You can really like deep dive a bit. And what you will get is your model returning you, just like a JSON form, it was really asked in the prompt to really have like that specific structure so that it's easier to manipulate after. But it will return you directly like the translation, the root cause, the action taken, and some other categories that you would like to have. Then what you will have in the process is usually still check, obviously, that your model is still extracting interesting information. And you will go see your business analyst, for example, in the context of that project, to make sure that those information are interesting. And what you will have is often maybe the first iteration that you will do is not the perfect one, so you will have to reiterate, adapt a bit the prompt, and give it back to the model and see if it's improving the results. Let's look at the results now. So just on the right side, you see the new information that are detected by the model. So instead of having an error cause that is deformed, here it's identifying, for example, that it's due to an impact damage. And then for the error category, it's like one of the category that was like, the classification of the company, you have like mechanically broken. And the action name here is quite interesting. It's identifying that it's really like an installation of a new flashing light and an altimeter and not just like customer damage, for example. So we can see that just with a very simple prompt, actually, that has been applied. So it's not, we are not discussing, for that first case, we really wanted to have a first example of a basic implementation of generative AI, so just prompt engineering, as we call it. There is absolutely no form of learning. We are not giving specific examples so that it can learn from it. We are absolutely not retraining any model. We are just asking a question that has been refined a bit with specific guidelines to follow. And you can already see that the value that has been created in terms of business is quite incredible. The performance, it has been assessed on a quite big subset actually, and it was like already 98.5% just with that simple implementation. And it was really outperforming the manual inputs. What we'll do, what you will see, by the way, on the future cases that we'll present is that we'll augment a bit in terms of complexity and see what more you can do, adding some complexity to those different generative AI implementations. So let's move on now to the compliance contributions.
Compliance contributions. So how can we ensure that we can implement compliance regulations without the heavy load on the data team who is already strangled? So we're just going to go through a few examples that will be quick and simple. So automated data mapping, this is a requirement of GDPR, which has at all moments you need to be able to say what kind of personal data you are storing, where you're storing it, and where you're using it. Where you're using it is where the issue lays. So when we talk about automated data mapping, this is something that we can quickly identify and know exactly where that information is being used. So when we're talking about compliance checks, we go back to the discussion of data quality rules being automatically generated. So checks that are automatically put in place and run on a schedule. Anonymization, this is something that is quite interesting and yet again a requirement of GDPR. And we can do this in several different ways, and GenAI can do it in all of them. So if we are doing it at the ETL, at the pipeline level, then generative AI can identify the personal data and anonymize it straight away. If we are doing it later when the data is being retrieved, then even those chatbot assistants, they allow you to interact with it, but when they see personal data, they don't give it back. They give it back anonymized or pseudo-anonymized. The same goes with data minimization. You probably faced this in the past, where you have a request coming in from a business user, and according to GDPR, the reply should be as small as possible to resolve the issue they are trying to resolve. So you shouldn't have any extra information in your data set, in your reply. So this is very hard to do, and you see that most engineers, they will just add a lot of extra fields to make sure that the request doesn't come back, doesn't bounce back. Otherwise, the business user will say, oh, I'm missing this. And there will be another iteration. So this is against the GDPR principles, and we can now ensure it with generative AI as well, as it will predict what kind of fields will be useful for the task that the person is trying to fix. Then legal updates, learning and awareness are a little bit put together. So we're talking about natural language interpretation of those regulations that are usually written in legalese, and it's very hard to understand, am I compliant, am I not? So everything that has to do with trainings or refreshment of policies, I can just interact with the bot and ask, hey, am I still compliant here? What is missing? And finally, we have the risk assessment. So this is pretty much looking at patterns that we cannot identify, be that we have access logs, for instance, and we see, or rather the generative AI can see, oh, this is a weird pattern. Someone is accessing this more often than we expected. Or even fraud detection when we're talking about transactional systems. So when we're talking about transactions happening in real time, AI is able to say this transaction is rather suspicious, this volume is rather suspicious, and the loop of transactions around this particular product is rather suspicious and needs further investigation. So finally, we come to integration, and arguably the heaviest load for the data team. And once again, we have 3 axes to try to diminish the issue. One is making sure that the data engineering tasks can be distributed a little bit, not just by data engineers, but by, let's say, regular business people. A high productivity gain for the data engineers that already exist in the company, and the knowledge gap, which is pretty much this asking around, that instead of trying to find the person that we can ask around, we can just interact with a chatbot or an assistant to get there. We'll go a little bit more in depth to each one of them, starting with citizen data engineers. This is pretty much empowering non-technical staff. So we have people that are not data engineers, but they can perform quite a lot of those data engineering tasks because they are assisted by it. And if we do have success rates of 99, 98.5%, that's pretty seamless, and we don't need data engineers to implement the small things. So those the large ones can be left to data engineers, and the small day-to-day, they can be done by the regular business users. Then we have the productivity gain for data engineers. We're talking about going faster, but the work is rather the same. So things are generated, the pipelines are generated, the ETLs are generated, and we just verify that everything is okay. So removing that manual workload of writing SQL, writing pipelines, debugging, all of that gets tossed out. And finally, closing the knowledge gap. Now, you know this for sure, there's always this senior knows-it-all at any organization, that if there's a newcomer, you will just ask that person. Even a more media or senior person from time to time will ask that person, hey, where can I find this? So this is the person that will know, has been there for a decade, knows where all the reports are, knows where all the data sets are, and we can close this knowledge gap with assistance. So once again, we are trying to reduce the human workload. Now, if we have someone joining, instead of asking the senior know-it-all, we can ask the assistant, hey, I need to fix an issue in a report. This particular KPI is not seeming correct. Where is it used? Oh, these are the pipelines that treat that specific data asset. Excellent. Now I can carry on with my work without crowding that senior know-it-all. So, in fact, all of these can be proven in real life, and we're going to see the productivity gain example. Again, arguably the more labor-intensive task of them all that can now be improved with generative AI.
Yes, thank you, Fernando. So, let's look now at a case, as Fernando mentioned, that is really related to the productivity gain that you will have in the integration framework, basically, and way of working. And what you will take as an example is a supply chain company. And basically, just to explain very briefly the context, let's say, of that project, it's a company who wanted to implement a data mesh initiative with innovative data products. It's very often that you will hear data mesh at the moment. It was also a very hot topic the last few months, I would say. So the thing is that in the context of that data mesh implementation, they had to do the manual data mapping from the source schema to the target schema completely manually. And that slowed the progress quite a lot, actually. It was very annoying because when you are implementing those data mesh initiatives, you want the data products to be on the market very, very, very soon and very quickly. And when you have like manual data mapping and manual work actually that are slowing down a bit the process, it's always something that you want to work on and find a way to automate that part to reduce the manual effort. So the question was how generative AI can help doing that. So in terms of technical aspects, if you remember the first case that we presented, we had like what we call zero-shot learning actually, so zero training involved, not giving any example. Here we are adding actually a level of complexity. So now we are not only giving a prompt to an API that is already trained and existing, we have what we call a chain model. And a chain model is basically just a sequence of predetermined steps that a program will follow exactly. And those steps can be calling a large language model within them, basically. So instead of having, if you remember the first case, instead of having like a full prompt saying, okay, let's translate, then let's analyze what was the error cause, and then let's analyze the actions taken, etc. Then here you can split that just to make it a bit more able to focus on one single task. You can split it in a chain, basically, and have like a chain for the translation, a chain for the discovery of root causes, etc. So this is a concept that we have implemented here in this case, but we also implemented what we call few-shot learning. So here you will just give a few examples to your model with the input and the output that you are expecting so that it can learn from it and see a bit what you are expecting as an output and make sure that it will provide you the expected one, basically. So let's have a look at the demo. So this is a solution that we have developed using Streamlit and LangChain as a framework. And it's just aiming to automate that data mapping that is done at the moment manually by the different users. Let me make sure, yeah, that it started. So what you will have is basically that solution that will automate the mapping from the source schema fields to the target schema fields. And you will have that user interface where you can select the different elements that you want to upload. So let's start with uploading, for example, the source schema information. Then you will do the same for the target schema. And what you will see here on that tab is basically like a summarization of everything that you have uploaded. What we advise usually to improve a bit the quality of the model is to have some comments mentioning, okay, what each field is representing and what it does. But if it's not present in the source schema that you uploaded directly, you can also add directly some separate type of information and asking it, for example, to perform like additional type of actions, like keep the 2 first characters of the country field. Then you will run the model, who will generate automatically the different data mapping lines. Sorry, it went a bit quick. And, and what you will see, going back on it here. What you will see is that it will automatically generate for you some transformations. For example, it will compute automatically the total price that has been defined in the target schema, but that was not defined in the source schema. It can also, for example, automatically understand that it will split the first name and the last name if it's something that you need to split in your target schema. And it will also, as you can see here, select basically just the 2 first characters of the country field. And it's really something that can be customized. You can give it like any indication in natural language of additional transformations that you want to do, and it will be able to generate it automatically in SQL. So what is quite interesting to understand for that specific case, actually, is that you will have, like really a level of complexity that is a bit above the one that we have presented before, but that it is already allowing you to perform like actions that are way more complex, let's say, like generating automatically a SQL code to map your source schema to a target schema. Maybe for something that would take days to a human, here you can generate it like in a few seconds or in a few minutes, depending a bit on the complexity of the transformations. And this is done completely automatically. So let's go through now the discoverability and accessibility challenge.
Thank you.
Thank you.
Right, so going back now to the discoverability and accessibility, the one that was most relevant for the room at least. So what is available in my organization and how do I access it? Now, we can divide this a little bit into 6 different categories, starting with chatting with your data. And this is probably the most important one of them all. So instead of trying to find a report somewhere or find a report that doesn't exist or requesting that report, I can just chat with an assistant and request specific fields or a specific result that is useful to me. The exploratory data analysis, which is maybe one of the most lengthy processes of data science, can now be done automatically. So everything that has to do with identifying patterns gets significantly faster. When we're talking about tagging or labeling, we're talking about labeling data, be it text, be it images, be it video. Even if we're talking about audio or sentiment analysis, we can pretty much tag all of our data assets relevantly. Then we have automatic descriptions for data products and assets. So we're entering now in the cataloging domain. So this is probably, or let's say, this is most likely the reason why data governance is usually discarded. So it takes a long time to implement, and it takes a long time to maintain as well. And maintaining it is just as important. From the point of view of implementing it, as soon as you're not maintaining it, it's garbage, it's useless, it will just go into disuse. But unfortunately, implementing it means a lot of descriptions, means a lot of writing, means a lot of knowing and introducing into a system all that you know, all that you changed, etc. So we can now do this automatically, including, so you see that it's automatic generation of metadata. We were already doing this, but AI does it faster. So depending on the sizes of data assets that you have, AI does it much faster. Then glossary, definitions, and linking. This is something that has always been manual, and now we can do it automatically. So instead of someone saying, this is what the business term means, we actually get, hey, this is what the business term means. Do you confirm this? And not just, this is a definition from your business, but here are all the data assets that are related to it, so you can find it when you need it. And we're talking about data assets linked to data definitions, and we're talking about them linked to each other. So hey, you're using this data set, here's another 2 or 3 that are relevant for you as well, or that are using the same kind of information when you're looking for. And we can do all of this, again, via Assistant, and lucky enough, we have the example about just that. So it's a real-life example about the most valuable of all of these, which is chatting with your data instead of requesting information to technical users.
Thank you, Fernando. So, third case. It's actually exactly the same context as the one that we presented before. So same company, same context, data mesh implementation. But what we have noticed actually is that to have a quicker go-to-market for the data products, it was not only about automating the data mapping, but also closing a bit that knowledge gap. We noticed that there was like a huge knowledge gap between the ERP operational databases and the data analysts themselves. So they were actually really like not knowing exactly what was in the data, where it was, how to map it, etc. That was like an issue that is clearly of accessibility, but also of discoverability. And we had, like, as very often in many companies, an issue of limited documentation. And what we proposed in this case is to try to aim to accelerating that time to market by using generative AI with just a simple chatbot that would allow you to directly discuss with your database and ask the questions that you need. So let's now introduce for that an additional concept, that is a bit more complex, but that is really promising and super interesting to keep in mind. So this is what we call the AI agents concept. What does it mean? If you remember before, we discussed about like the chain models that were like just a succession, a sequence of different actions that you will ask your algorithm to perform, but that are really like static and hard-coded. It's defined by the human, you ask it several steps, and it will do them, basically. In this case, you are doing something different. You are letting the algorithm decide for you, basically. You don't have to let him know exactly the different steps it has to go through. It will be able to, as a large language model, to really reason and choose what is the right sequence of actions that it has to perform just to answer the request that you had made in the prompt and the question that you asked. How does it work in practice? So you will have like a data analyst, for example, querying the agent in natural language. So you will ask, okay, I want, for example, to retrieve that information about my database. And what it will do for you is automatically translate it to a query in SQL, for example, send it to the database, and then the database will, as actually someone, as a data engineer who would code a SQL line, it will just give you back the answer. And what the agent will do for you is that it will translate it again in natural language before proposing it to the data analyst. Just to make, like, how to say that, to be in the middle and be a translator. But a translator that knows very well your database and what's inside it. So let's look at the case. So here, in this situation, we also have developed the chatbot using Streamlit and LangChain. What is important to keep in mind is that LangChain, by the way, has released like a framework that is super good and super easy to use for the different AI agents. So I encourage you to have a look at it. And it will allow you to just very simply chat with your database, ask it any question that you would like to ask. In this specific situation, we'll do as if we were like a data engineer, for example, and ask some questions about your database. So here in this case, we ask it to describe the tables that you had in it. You will see that it will automatically retrieve for you all the different tables, but also understand what each field probably means. So it will give you a translation in natural language, an explanation in natural language of what the different fields mean. Another thing that you could do as a data engineer is ask it to generate all the DDLs code for you, for example. And it will automatically like have the creation of the table code that you see here for the order table, and it will show you the first sample of rows just so that you can check actually that it corresponds to what you expected so that you know a bit what's in it, basically. But let's imagine now that you are not a data engineer, but you're rather like a business analyst or a data analyst who wants to have like a business question answered. And what you will do here is basically ask it the top 5 products sold in France in terms of quantity. It's like, just to clarify, this is like an anonymized database that we have used for that example. This is the reason why it's not like supply chain type of information that you see. But just to illustrate a bit, it will give you like the top 5 of those products that are sold and list it directly for you in the chat, and you can ask whatever question you want to that database, and it will automatically retrieve it and give you the information, which is quite interesting. So here, with this case, we can see that adding like an additional level of complexity, which is the AI agent concept, you can do like things that are really creating a value that is incredible in terms of accessibility and discoverability. Now, instead of having to go through every single person in your company to understand what's in your data, you can directly chat with the database in direct using natural language. So let's move on now to the future landscape. What is quite important now is to understand a bit, okay, we have presented quite some things already, but what's in the pipe? What's coming? What are like the new changes that we still have to wait for, basically, in the future? So one thing that we have noticed that has been developed already in the last few months, but is obviously like an investment that is a continuous one, is the move from data platforms to what we call data intelligence platform. If you look just at Databricks, for example, they invested massively into this just to have basically a value that is created by integrating directly artificial intelligence in their process internally and to automate already a big part of the workflow. The second one that we see is the appearing on the market of competitive open source models. Before it was like mainly commercial models that we had for everything generative AI related, but now we have those open source models that are arriving on the market quite with a lot of strength, let's say it like this. You have, for example, the Llama 3 model from Meta, but you also have the DBX model coming from Databricks that is actually already outperforming quite a lot of commercial models. So it's really good to keep that in mind, that open source is getting quite a lot of strength. Then the third point is also quite interesting. It's the rise of domain-specific models. As you can see, and as you probably know, all the chatbots and the different GPT models that we are using at the moment are quite generic, as we can see. It's really like you can ask it whatever question on whatever domain and it will get an answer for you. But what we have noticed is that when you go into specialized domains, then you start getting a lot of hallucination and information that are completely wrong. Let's imagine you're like someone in the medical sector and you want to have a specific answer to a question. You better not trust ChatGPT for this, for example, because it will give you some information that are not completely trustable. But what we have is the rise of domain-specific models. So we have a lot of models that are being developed specifically for some industries and specifically for some for some domains that will really know all the nuance of that specific field and be able to answer your question and to cover your needs for that domain. The fourth point is the move from the proof of concepts to the minimal valuable product. Because as we mentioned, many companies are already investigating what generative AI can do, but the question is, okay, how do we move this into production actually? Can we use it at scale? Is it feasible? Is it easy to do? And for that, we have quite a lot of principles that are appearing that are, for example, operational ones. Like MLOps, we now have a version that is really focused on large language models, which is like LLMOps, to ensure that you keep the same quality at scale, basically, and the same performance. The fifth one and last one is the one that we presented just before with the last case, is what we call the agentic approach. It's very, very early stage yet. It's already providing quite a lot of value, but it will continue to evolve. Now we really want to move from some tasks that are really like defined by the human, etc., some questions that are really like hard-coded in a way, to some models that are now able to take decisions and to take actions completely autonomously, basically. And in terms of decision-making, this is obviously doing like a crazy difference.
Just a small consideration on adoption rates. So what we see now is that we are approaching the chasm, so pretty much the point of no return from where the majority of the companies will be doing massive adoption. So it will be end-to-end, pretty much everyone will be adopting in one way or another AI to potentiate their teams in whatever sector, right? Today we are funneling down a little bit and sticking to data bottlenecks on the data team, but this could be applied to anything, right? Marketing, whatever may be it. So in fact, we see that most vendors are really on the innovator side. They are really pushing out solutions that are extremely valuable. We have some early adopters that are industries that pretty much are asking now for custom solutions, right? So the examples that we have been showing so far, those are custom routes, but we are just about to break it. So this will still happen in 2024. That's our belief. So in a few more months, we will see that the majority will be implementing. So throughout the end of 2024 and 2025, there's still time, of course, to do implementations. It is just a matter of decision. How do we want to capitalize on it? How do we want to do it as a competitive advantage? Do we want to do the custom route, or do we want to do the alternative? And we will walk through that alternative in a minute. We just wanted to mention that now is the time for that competitive advantage. Still in 2024, things are going to be massively changing. Right, so how can we start today? Radia will walk you through it.
Yes. Let's maybe first start with 5 things that are quite important to keep in mind when you are using large language models, because obviously it's something that is creating a lot of value, but you still have to keep some specificities in mind. First of all, watch out for bias. It's a bit like for the humans, actually. You have bias in each of one of us, and it's important for the algorithms that are actually learning from data created by humans, it can be like on the web, books, etc., that you will also have bias that will come out of it. The second one is understand the why. It's very black box. It's an issue that we had maybe already with machine learning before, but it's getting like more and more complex for generative AI. And it's also hallucinate, as we mentioned before. It's sometimes creating like answers that you would not expect. So to try to mitigate that risk, what is important is really to try to figure out basically what's the reasoning behind when it gives you an answer. how it was thinking and why it gave you that answer specifically. The third one is actually just not just a nice to have, it's actually a legal requirement. It's keep your data private. Be careful with that. Don't feed any personal information when feasible to your data model. It can be like through ChatGPT, but also through the different models that you train locally, let's say in your private network. It's important to be very careful with that. The fourth one is feed it good data. As we also saw in machine learning in general, garbage in, garbage out. It's still true for generative AI. It will basically give you answered from what it has learned in the past. So if it's completely false, the information that you give it as an input, it will be false as an output as well, basically. And the last one is also an important point: prevent bad use. We still have some human involvement in the sense that you are asking the questions, you are getting some prompts into it, etc. And it's important to be sure that everyone in your company is not using generative AI with the wrong intentions. Let's say it like this. Now, what is also important is to look into the different vendors and what they are doing.
Right, and just a small note on this, in fact. Those are really the two starting options that we have today, right? We either go custom or we go with a vendor that is already investing massively in GenAI, but there are some things you need to be aware of if you want to follow that route. So it is true that those vendors are investing massively in AI. It is true that if you want automatic tagging of personal data, Snowflake already has it out. But a few remarks on this: not everyone is ready, and not everyone is ready at the same moment or at the same level, and you might not see it. And this is the point that we need to put some focus on. If you want to chat with your data, you will see that Informatica, for instance, the Claire GPT, as it's the product name, exists, but it's not out for general availability. There's a reason for that. It might be slightly illegal. So downloading all of your data and allowing people to interact with it starts to break some of the legislation of where your data should reside. So there's plenty of things that are now being tuned so that these things can be released to the public. So you might see that you're tempted by a product and then finally you cannot use it just yet. Right? When we're talking about catalogs in specific, we have Atlan, Informatica, Xenia, for instance. What you will see is that a lot of algorithms are already using AI in the background. So all of these AI possibilities, they are already being used, exploited. However, you may not see it. They're usually there for classification, so everything that has to do with automation, automatic documentation, etc., is already there. But search, for instance, which can go both ways, the traditional search or the artificial intelligence search, it's a decision on what is most performant now. So whether you're using it or not, you might not be too sure. But to make matters worse, and this is the crucial bit of this, the smallest your implementation, the worse the result will be. So you might not have access to it because you're starting out. I'll make more sense of this. If this is your first data catalog implementation, let's say, there's nothing in the database or there's nothing in the repository of the catalog that AI can use to generate things, right? So here we run into this problem that the features exist, but they are hidden to you as you start out because it's a matter of trust. We need to ensure that at least 98.5% of accuracy to ensure that people are trusting the catalog. If they don't trust, it will be a catastrophe, it will be a waste of money, and it will be just disuse. For that reason, they hide those features until your catalog is large enough that your generation is reliable, and then they open them. So be aware that if you want to start out, but it's your first catalog implementation, you might not see it straight away. So this is something to consider when we go not the custom route, but the vendor route. Of course, plenty of things are still available from the different vendors. They all are doing an amazing contribution. They all are releasing things to the general public, some of which might not be accessible for legal reasons, some of which for tuning, some of which because you're just starting out. That's just something that we need to be aware of.
So the big question for you now is, are you ready to embark actually at your own company? Is it something that you want to do, and what you should think about if you want to start that implementation? The first one, and definitely one that is sometimes a bit underestimated, is the strategy, but also the governance. So you have to upskill your executive committee, because it's important to have sponsorship and to have the executive committee understand a bit like what value it will bring, but what is also the risk and mitigations that needs to take place in this. But also to define your short-term and mid-term strategy, keeping in mind the robust governance that needs to come with it, basically. Then the second point is the project selection. Now that you have your strategy, you need to pick the right AI projects and the ones that will really create value for your company and not for all the others, let's say, on the market. And capitalize on the really having like a clear governance, but also be able to make the decision whether you will go for like a vendor option that was presented by Fernando, or you will start building it from scratch, like the cases that we have presented before, for example. Then the third one is also the talent and skills. It's important to continue to really build like a culture around generative AI and artificial intelligence in general, actually, within your company, and to really invest in all the talents that you have in your company to make sure that they can really grow with it, with the trends that are present on the market, and that you always stay ahead of the curve and not be always like trying to run after it, let's say. Then you also have the tech infrastructure. Okay, you want to start, but you need to have the tech going with it. Sorry. So like sometimes you might need to upgrade some of your technological landscape to be able to start those implementations. In terms of data management, what is important is, as we discussed, garbage in, garbage out. It's important to have good quality data. And the good thing for this is that you can actually leverage generative AI to help you with this. But the last point, and it's also quite important and often legal actually, is to also focus on everything that is ethics and regulations. So make sure to use AI responsibly, but also to mitigate all the risks that come with it that we have presented before, and really always be aware of like all the new compliance regulations that come, and to make sure that the company is following those guidelines and being responsible on the legal aspects, basically. The good thing is that we can help you with it. Whether you are at the stage of really like still understanding what you can do, what is generative AI, what does it mean, etc. Whether you are already starting to apply it through like an AI strategy or some first use cases that are implemented, or if you are already in the last stage of really scaling and transforming all your business using it, putting in place like an AI governance, defining a task force for it, and upskilling all your different teams, having like an architecture using large language model ops and processes, etc. So if you need any help for that, we are here. Now, time for questions. Do you have any question? I think Wout will also have the online questions that you can mention, but we can already start with the one on site, if there is anything that comes to your mind.
If not, let's do the ball rolling.
Absolutely, yeah.
Okay. Thank you for a great presentation, both of you. From the audience, I actually have two questions open here. Aren't LLMs confirmation bias or even AI in general?
Can you, sorry, repeat the question?
Aren't LLMs confirmation bias or even AI in general?
Yeah, I see what you mean. Okay, so is there like any confirmation bias present in the large language models? As we presented, actually, there is bias in general, I would say. So confirmation bias might be one of it. I think it's also a bit related to one of the things to keep in mind that we mentioned, that we really have to be careful with the way we utilize artificial intelligence and generative AI. Confirmation bias, it's you can trick the AI to give you a specific answers on the way you are asking the question. But I would say that most of the providers and OpenAI also are really like trying to add some guidelines and some, how to say that, barriers within the algorithm and within the solutions to avoid a bit that kind of behaviors. But indeed, it's something that definitely you should keep an eye on.
Okay. Perfect. And then there was another question on the SQL agents. What are the requirements for database level data models? Is it so that data models need to be specified super clearly, or is it able to interpret links in the tables between themselves or with proper primary or secondary keys?
Do you want to take this one?
Sure. Yeah, it can indeed. So if everything is modeled and everything has the linkage with foreign keys, it's pretty much identified. You don't need to specify anything. There is a layer of interpretation that is done by the agent itself. It's pretty much a normal interaction from that moment on.
Okay, super. And there's one more question here that I see. Yeah. How to accelerate AI in novice teams? How would you do that, or what's your opinion in that?
Yeah, it's a very good question, and for this one I can actually come back on this slide. When you are actually at the stage of understanding what you can do with it, especially when you have like a team that is still novice at AI, artificial intelligence, I would say that what is quite important is to start with the upskilling, but also the general knowledge of what can be done with artificial intelligence, trying to learn the basic concepts and really building on top of it so that you can grow in complexity and usage. For everything that is related to not only learning what generative AI can do for you, it's quite important also to start applying it. So if you have any use case that you think about in your own organization that can help you use generative AI and create a lot of value with it, it's often the best way to learn, actually.
Okay. I think those were the questions of the audience online. So thank you very much. Someone
Perfect.
else here has more questions? No?
It's okay. If something comes up, we have time after.
Absolutely, we have time to chat after. And also, if you have any question that comes to your mind after, you can always contact us, obviously, to have like a separate discussion and go through specificities of your company or your business in more details.
Right. Thank you, everyone.
Thank you very much.
Thank you.